Hi, this video will cover section 2.3, polynomial and synthetic division. The objectives for this section will be to use long division, just like in elementary school, but now we're going to use it to divide polynomials by other polynomials. We're going to use synthetic division. This is very cool. You're going to love it. To divide polynomials by binomials of this form. Now, the catch is that we cannot use it all the time. So first, we got to learn the hard way with long division. So synthetic division can only be used when your divisor is of degree 1. It's a binomial and is of degree 1, and the leading coefficient is also a 1. Also, we're going to learn how to use the remainder theorem and the factor theorem, and we're doing all of this with the purpose of finding zeros or those x values for which the y is equal to 0. We also call them roots, we call them solutions, and if they're real, they appear as x-intercepts on our graph. Okay, so let's get started. So we have we have a polynomial here of degree 3, and you could see that the leading coefficient is a positive 6. Now, it's important to check that your polynomial is, don't just look at the first term, but make sure that it is in order. And it's better practice if you get used to write it in descending order. Meaning you start with the biggest exponent and then you work your way down until the constant term, because that one is believed to be of exponent of degree 0 and this is degree 1. Okay, so we have the polynomial. You could see the graph on the right side, and for this polynomial we say that it is of degree 3 because that is the highest exponent. And so being of degree 3, the number of turning points that this polynomial can have, and we discussed this on the previous section, is going to be n minus 1, which will be equal to 2 turning points. And we can see them clearly here and here. However, being of degree 3, it tells us that it could have at most 3 zeros. And those zeros are going to appear on the graph. If they're real numbers, they will be x-intercepts. And so we could see them there. We have 2 as a 0. And then we have another 2 here. A couple more. Here the 0 is actually 2, such as x equals 2. That's one of the zeros. The other zeros, we don't know what they are, so we're going to learn some ways to find them. So since the 0 is x equals 2, this is the 0, we have that the factor that comes from that 0 is going to be x minus 2. That's the factor. And that is because if we take the 0 across as positive, it will turn into negative. And then the right side will be just equal to 0. But when we talk about the factors, we just want what's inside the parentheses. We don't want the whole equation. So that is useful because if we divide our polynomial of degree 3 by the factor which is of degree 1, and we have it here, x minus 2 is the factor of f, and so what that means is that there will be another polynomial, and that will be, if we start with degree 3 and we subtract 1 from the factor, then there is another polynomial that will be of second degree, such that we could multiply x minus 2 times that polynomial. So let me give you an example with numbers. So let's say that we have, let me think about a number, 27. And so we could factor 27 as the product of 9 times 3. That would be an example. So here, this is a factor, and here's the other factor, just like numbers also have factors, like that. Okay, so to find that polynomial that we're gonna be looking for, and this will be of degree 2, we're going to use long division, because I told you we gotta, you guys gotta learn the hard way first. Then I'll teach you the shortcut. So let's do that. So first, let's do a quick review of long division, like when you were in elementary. Let's see, so 427. Let's see, we'll divide by 5. So let's see, 5 divides, it cannot divide 4, but it could divide 42. So we take the first two numbers inside the dividend. By the way, it's important to know this terminology. The number inside the division symbol, it's called the dividend. The number outside, or polynomial, the one performing the division, and I don't mean you, divisor. What we get as the result is called the quotient. And then we'll have some steps here, and then at the end we will have the remainder, not reminder, but remainder. Oops. Remainder. Okay. So let's continue doing that with our long division that we have here. So then we take the first two digits from the dividend, and we say 42 divided by 5 is going to be equal to 8. Then we multiply. 8 times 5 is equal to 40. And then we subtract the numbers. And I know, some of us skip this step. Please do not skip this step when you are dividing polynomials. So you write the product of 5 times 8, but then you have to be very careful that you change the sign to negative, because you will be subtracting. So in the case of that you get a negative number there, then you will change it to the opposite, which will be positive. So then we subtract, we get a 2, and then we drop the next digit, which is a 7. Then here 5 will go into 27, a total of 5 times, and then we multiply 5 times 5 is 25, and then we must change the sign to negative. And so 27 minus 25 is equal to 2. And then we stop once the remainder is smaller than the divisor. So 2 is smaller than 5, that's how we know to stop, unless we want decimals, but we won't be doing that right now. Okay, so now we're going to do the same, but with the polynomial. All right, so I am going to write down my divisor. And then my dividend. I have to make sure that it is in descending order. And please make sure that you copy all of your signs correctly. And that is the hardest part about doing division, long division, that sometimes we might forget or overlook one of the signs. Okay, so we're going to take the first, we have two terms here, binomial, so we're going to take the first two terms here. And we're going to say how many times can 6x cubed be divided by x. And so the answer is going to be 6x squared. So we're going to write that up here, 6x squared. If you are not sure why, there's nothing wrong with having some scratch paper to do your work on the side. So if you have 6x cubed, and then you divide by x, it will be a 6, and then you subtract the exponent, so that's why it's 6x squared. Okay, now we're going to multiply 6x squared times x, and so that will be 6x cubed. It's kind of like we get the same, right? But not really. Then 6x squared times negative 2 is negative 12x squared. Now, I say we don't get exactly the same, or I say not really, because we still need to subtract. So this positive 6x cubed goes to negative, and the negative 12x squared goes to positive. Now we can subtract by combining like terms. So this 2 will go to 0 because they're opposites. And here we have positive 12x squared minus 19x squared. So we keep the number, the difference negative, because negative 19 has a bigger absolute value. And the difference between 19 and 12 is 7. So 7x squared. Then we drop the next term, which is plus 16x. Now we're going to do the same, take these two terms, but we're only going to divide that one by x. So if we have negative 7x squared and we divide by x, we're going to subtract 1 to the exponent as well, so that will be x. So negative 7x. Now we're going to multiply negative 7x times x is positive 7x squared. Oh no, sorry, that's negative. Negative times positive, yeah. So it's negative. Then negative 7x times negative 2 is going to be positive 14x. Now we need to subtract, which means we change the signs to their opposite. So this is positive, and the other one will change to negative. Remember, that's because we have to subtract. Now let's combine like terms. This 2 will cancel out. They equal 0. And then 16x minus 14x is positive 2x. Finally, we drop the next digit, negative 4. And now we're just going to divide 2x divided by x. That one's easy because you could see the x divided by x is equal to 1. So 2 times 1 is 2. And it's positive, so we must put a plus 2 there. So then we multiply 2 times x. That will give us 2x. Then 2 times negative 2 is negative 4. And let's not forget that we have to subtract. So this turns into negative 2x, and this will turn into positive 4. And then nicely, they will both cancel out, so the remainder happens to be 0. Now, this will not always happen, but the reason this happened is because we already knew that x minus 2 was a factor. So anytime you divide a polynomial by a factor, of course, as long as you divide correctly, and of course, as you have the right factor, you should get a remainder equaling 0. Okay. Now, what we got, well, that's all we had to do for this polynomial. Now, it says here, let's go back up and we'll write it there. So here, okay, so this polynomial here, the one that we had in the dividend, oh, and I'm missing a 3 here. The one we had in the dividend, that is f of x. So what we're saying is that f of x, which was equal to 6x cubed minus 13, not 13, but 19 x squared plus 16x minus 4 is equal, I'm going to have to move my camera, is equal to the divisor, which was x minus 2. And remember, we found that one from the graph by looking at this graph, and we say the 0 is x equals 2, so the factor is x minus 2. So once we finish our long division, we got that the other factor, which is here what came from the quotient, was going to be 6x squared minus 7x and then plus 2, like that. Now we could factor this even further. I'm gonna just make a little bit more space. Or we may not be able to factor it even further, but if we weren't able to, then we could use quadratic formula to find the x values. So I'm going to pause this video and see if I can factor it. Okay, so I'm going to just factor it here. I think it is doable. So let me show you how I factor polynomials where the leading coefficient is not a 1, because if we use that trial and error method, it could take us a while. So what I do is I multiply 6 times 2, and it gives me positive 12. So then I'm going to list the factors of 12, like 1 and 12, and then we also have 2 and 6, and then 3 and 4. Now I want a combination that when I add them, I get this number in the middle, the 7x. And that will be if I add 3 and 4. However, I want them both to be negative. So what I'm going to do is take that polynomial, this polynomial, and let me use up here above the problem. So we have 6x squared minus 7x plus 2, and we're trying to factor it. So we're going to say that this term in the middle is going to be negative 3x minus 4x. Isn't it true? So we're like breaking that term into 2 terms so that we can have 4 terms. Why do I want 4 terms? Well, because I want to use factoring by grouping. And I know you have heard it before, but this might be a nice review. So what we do when we factor by grouping is we're going to group 2 terms at a time. So we're going to group the 6x squared minus 3x. And then these are not multiplying, so you have to put either a plus or a minus there. I like to just keep it as a plus, just so I don't get confused with what goes inside the other parentheses. Trust me, it helps. So if I put a plus, I just have to keep the sign of this negative 4x inside the parentheses and then the plus 2. Okay, so then I'm going to see what I can factor from these 2 terms. What do they have in common? Well, they can both be divided by 3, but also they have an x to the first power in common. So that's going to be what I factor out. And if I factor out 3x from 6x squared, I get 2x. If I factor 3x from negative 3x, I get negative 1. Now, from my other group, what I can factor out, they have in common that they can both be divisible by 2. But what I want to do instead is factor out a negative 2. And you'll see why in a minute. So if I factor out a negative 2, then negative 4x divided by negative 2, I will get a positive 2x. Right? Negative 4x divided by negative 2, you get positive 2x. Then if I get negative 2 and divided by, the one on top here is positive 2 divided by negative 2. So I'm going to get negative 1. So that goes here. And that is the purpose of factoring by grouping, that you group the terms so that you have one common denominator, greatest common factor, that's what it is, in common, which is right there. It happens to be a binomial, there's no problem with that. So that will be one factor, 2x minus 1, and the other factor comes from here and here, 3x minus 2. Just like that. And so now we have factored that second degree polynomial, this one right here, we have 2 factors for it. So here we have 2x minus 1, and the other one is 3x minus 2. What is that? How is that useful? Well, because if we equal that polynomial to 0, we could say that each factor equals to 0, and from here we could solve for x. So 2x will equal to positive 1, and then to finally solve for x, it will be x is equal to 1 over 2. So that would be our other 0. Now for this other factor here, 3x minus 2 equals 0. We have 3x is equal to positive 2, so therefore x will be 2 divided by 3. So now we have all of the zeros. This one, I'm going to move it over here so you can see it better. I was missing a little part. So x equals 1/2. Was it 1/2 or negative 1/2? Positive 1/2. X equals 2/3. Those were the other two zeros that you could see here. Here we have 1/2, and here we have 2/3. So there you have it. Those are the three zeros. Let me just write them there. We worked so hard for them. So this one here, x equals 1/2. And this one here is x equals 2/3. So as you could see on a calculator or on Desmos, they usually, more than likely, will give you those numbers as a decimal. And WebAssign is going to want for you to enter the exact answer, meaning they want fractions, they want rationals. So of course the technology is great to check your answer, but you still need to know how to find them by hand. Okay, so if you guys need help with factoring, I do have a few videos on my YouTube channel. You could also send me a question, but I would strongly encourage you to use the the online tutoring services, because you also earn extra credit. Okay, so let's do another long division with polynomials here. And we have the dividend this is what is being divided, and here x plus 1 is going to be the divisor. So let's see what we get if we divide those two. Okay, so we're going to take x squared and divide it by x. That will give us x. You could place it above the x squared or here. That will probably be better. Then we multiply x times x, x squared, x times 1, positive x. Now we need to subtract, so that means we change the signs. So this positive sign turns into negative. Now we combine like terms. This goes to 0. 3x minus x, 2x. We drop the next term, plus 5. Then we divide. 2x divided by x is equal to positive 2. So now we multiply 2x times x, positive 2x. Positive 2 times positive 1, positive 2. And so now we need to change our sign. So that goes to negative, and this one goes to negative. So 2x minus 2x, 0. 5 minus 2 is equal to positive 3. Or we could just say just 3, right? So that 3 is the remainder. What does this mean? That x plus 1 is not a factor of the dividend, and that's why we get a remainder. So if the remainder is 0, we could say the divisor is a factor of the dividend, but if the remainder is not 0, then it is not a factor. The divisor is not a factor of the dividend. Okay, now this problem here, let's see, if we have the number, let's say 27, and we want to write it as a fraction, let's say 27 divided by 2, let's say. So that will be equal to, what would that be? 13? Yeah, right? Because 13 times 2 is 26. Or we could actually do this. Let's do this instead. So 26 divided by 2 plus 1 over 2. So I'm splitting the fraction, and then what I'm going to do is say 26 divided by 2 is 13, and then I'm going to have plus 1 divided by 2. That's a way to write 27 halves. Or we could also write it this way. 27 is equal to the product of 13 times 2, right? That will be 26 plus 1. So you could see here in this form, the 2 divides the remainder and also the dividend. And this form, the 2 is only multiplying the quotient. So if you look at it, you know it's true. 13 times 2, 26 plus 1, 27. Or we could also look at it as a fraction form. A mixed fraction, 27 halves, is the same as 13 plus 1 half. Or 26 halves plus 1 half. All three are true. Okay, so that is what we call the fractional form. And we could write the result like we had here, the 27 over 2, that is our dividend divided by the divisor. That was my example. And then the quotient, it was the, what do we call that? Oh, when we had that 13, remember? The whole number. And then the 3 plus x plus 1 was kind of like what we had as 1 over 2. Let's just write it here. The 27 over 2 equals 13 plus 1 half, which is how we, the number that we use to explain that. And so we have the same thing. Dividend is the 27. Here's the polynomial of degree 2. The divisor is x plus 1. Here my divisor is 2. Here my quotient is 13. With our example was x plus 2. That's what we got on the previous example, the one that we have here, x plus 2. And then we had 3 for the remainder, so that 3 goes here, but we still use the 2 as the divisor. So just like a mixed fraction. And this is what we call the fractional form. So that implies that the dividend, which is here, is equal to x plus 1, which is the divisor, times the quotient, which is here, and then plus 3, which is the remainder. So I'm going to write the same, but with our example with numbers. We had 27 is the same as 2 times 13, and then plus 1, right? 2 times 13 is 26 plus 1, 27. So this part right here is what we call the division algorithm. So the very first one here is fractional form. And the second one is the division algorithm. So with WebAssign, you need to be careful and to see how do they want you to enter your answer? Do they want you to use the division algorithm, or do they want you to use the fractional form? So make sure you do write something on your notes. Okay, the division algorithm in general terms, we have here x squared plus 3x was our dividend, the function that we take inside the division symbol. Then x plus 1, that was our divisor right here. And then q of x is our quotient, which in this case was x plus 2. Here we call it the quotient. And then, let me highlight this one. And then we have finally the remainder, which in our example is a plus 3. And here we have remainder. Okay, so the division algorithm, it says if f of x, the divisor, the dividend, and d of x, which is the divisor, are polynomials such that d of x does not equal 0. This is very important because we cannot divide by 0. You should know that by now. And the degree of d of x is less than or equal to the degree of f of x. So we want to make sure that the degree of the divisor is of lower degree than the dividend. So there exist unique polynomials, q of x, which is the quotient, and r of x, which is the remainder, such that this statement is true, where r of x equals 0, or the degree of r of x is less than the degree of d of x. So we could have a remainder that is a number, or we could have a remainder that is an algebraic expression, like, I don't know, x plus 2. So we just have to make sure that the degree of the remainder is lower than the degree of the divisor. Yes, that's how we know we stop dividing. And if the remainder of r of x is 0, then the divisor divides evenly into f of x. In other words, d of x and q of x are factors of f of x, such that we could just write f of x as the product of d of x times q of x, and then the remainder is just 0. So we don't even need to write the 0. I'm just showing it here to you guys. So that's what happens when you get a remainder of 0. Okay, so the division algorithm can also be written here. This is like the fraction form that we had from the other page. Remember when I had my example, 27 divided by 2 is equal to 13 plus 1/2. Looks just like that. So in the division algorithm, the rational expression f of x divided by d of x is improper because the degree of f of x is greater than or equal to the degree of d of x. So on the other hand, the rational expression r of x divided by d of x is proper because the degree of r of x is less than the degree of d of x. So same thing as fractions. I know you might not like them, but you had a reason to learn them in elementary. This is improper, and here this one is proper. So before you apply the division algorithm, you must follow the steps. 1, write the dividend and divisor in descending powers. Remember, we start with the highest exponent, or larger, from larger to smaller. Exponents, not the coefficients. Exponents. And keep your constant term at the end, because that's the one of smallest degree. Then second step, insert placeholders. This is so important. With 0 coefficients for missing powers of a variable, and we will see that example in a minute. Okay. Oh, no example. Let me give you an example here. So if you have something like, let's say, 6x to the power 4 plus x to the power 2 minus 1. Here, yes, it is written in descending order. However, it is missing. It does not have an x cube. And also, it doesn't have an x term to the first power. So I'm going to use placeholders. And I'm going to be using 0 as the coefficient because that's like it didn't even exist. And remember, we said we had no x to the first, so I'll put a 0 there and then continue. Even if we were missing the constant term, this is very important, not a lot of people know this, even if we were missing the constant term, especially for synthetic division, more for synthetic division, you still need to add that constant term at the end. Remember, I said we had no constant term, so then you will still add a 0. So let's see why this is important with synthetic division. So we have what we're going to do. This is a nice shortcut to long division. However, you cannot use it all the time. You can only use it if your divisor is of this form, meaning a monomial with a degree of 1 and a leading coefficient of 1. So you can use the shortcut called synthetic division. So for the synthetic division, we make the variables disappear for a little bit, and then we put them back in our answer. So what we do is we just take the coefficients of the dividend, and that's what you see here as A, B, C, D. Then we take the constant term of the divisor and we use it here. However, because remember how we said if the factor was supposed to be if the factor is x minus k, then the 0 will be x equals, if we take this minus k across the equal sign, it will be x equals k. And so that's why we put a k here, positive. So also doing that, it guarantees us that we'll make less mistakes because we will not have to be changing signs or subtracting. So it's a lot easier. We just add vertically or combine like terms, because some terms might be negative, but we will still add them. All right, so the pattern will be you multiply the coefficients of the dividend by k, and then, well, first of all, sorry about that, you drop the first term, or coefficient, I should say, and then you multiply k times a, and then you write it below the next coefficient. Then you combine like terms, and whatever you get here, you're going to multiply that by k, and then you combine like terms, and then whatever you get there, you multiply by k, and then you will put it here, and then you combine like terms vertically, and then whatever you have at the end, that is your remainder. Your remainder may also be 0. So we're going to do an example next. So also the vertical pattern you can see here is to add the columns, the terms in column by column, and then the diagonal pattern, like what we're doing here, is to multiply the results by k. So let's see the example now. And first we check that the dividend is written in descending order and that we're not missing any powers in between. As you can see here, we do not have an x cubed. So we are going to put a placeholder with the number 0. And that's it. That's the only one we're missing. So just so you remember, the 1 is representing the x to the 4th. The 0 is representing that there is no x cubed. The negative 10 is representing the negative 10x squared. And the negative 2 is representing the negative 2x. And the 4 is just the constant term. Let's use C for constant. Now, since we are dividing by the factor x plus 3, well, we don't know if it's a factor, but the divisor is x plus 3. So if we consider the opposite of plus 3, just like if you were going to solve for x and this was an equation, then you know that plus 3 will turn into negative 3. So that is the reason why we changed this to a negative 3, even though you see an x plus 3 here. You always do that. You want to take the opposite of the number that you see here. So let's get started now. We're going to drop the first term, which is a 1. Then we're going to multiply negative 3 times 1, which is negative 3. Then we're going to add vertically. So 0 minus 3, or 0 plus negative 3 is negative 3. Then we are going to multiply negative 3 times negative 3, and that will give us positive 9. Then we're going to add vertically. Negative 10 plus 9 is negative 1. Then we're going to multiply negative 3 times negative 1, and that will give us positive 3. Then we're going to add vertically, and negative 2 plus 3 is 1, positive. And then lastly, we're going to multiply 1 times negative 3, and that will give us negative 3 again. So 4 minus 3 is equal to 1. I'm just going to check my work quickly because my dog was distracting me. Okay, so it's fine. So since we started with something of degree 4, our result is here. Those are our new coefficients, and the 1 is representing that we have 1 x to the 3rd power. Why to the 3rd power? Because we're dividing by a divisor of degree 1. So 4 minus 1 is 3. Then the negative 3 here is representing that we have negative 3x squared. The negative 1 here is representing negative 1x. The positive 1 is representing plus 1. And then for the remainder, this is going to be a fraction. 1 over, and we're going to use the divisor in this form, x plus 3. And so that is what the whole polynomial was, the original dividend. X to the 4th minus 10x squared minus 2x plus 4. So here we have it written down by using the division algorithm. So here is the quotient and the remainder, and here we have the dividend. Here we cannot say that x plus 3 is a factor because the remainder is not a 0. Okay, we are going to look at the remainder theorem now, and to use the remainder theorem, we're going to be using the same synthetic division that we just learned. So it will be an extra example. And the reason we call this remainder theorem is because we use the remainder. And the remainder is going to be equal to the function value as in you were substituting the digit that you use in synthetic division. So, for example, if I take this example from here, and we say this was the divisor, right? X plus 3. However, we use the digit of -3. So if I was to ask you what is f of -3, you know that you will substitute a -3 here, here, and here for every x that you see there. So let's do that. We will have -3 to the power 4. We will have minus 10 times -3 to the power 2, and then minus 2 times -3, and then plus 4. And this will be equal to -81. Here we get positive 9 times -10 is -90. And then from here we get positive 6. And I feel like I did something wrong. Oh, I'm sorry. -3 to the power 4, that should be positive 81. Oops. And -2 times -3 is -6, and then plus 4. There we go. Now it will work. Okay, so if we consider the positive numbers, 81 plus 6 plus 4, that will give us 91. So 91 minus 90 is equal to 1. So what does that mean? That the function value at -3 is equal to 1, meaning if x is equal to -3, the y is equal to 1. But what did we also get as 1? And that was the remainder that you see here. And so that's why we call it the remainder theorem. So in your exam, if I say use the remainder theorem, please use synthetic division. Do not do direct substitution, or I will count it wrong. This is what I call direct substitution, or we all call direct substitution. And using synthetic division to find the remainder, that is actually applying the remainder theorem. So let's see what we would get with this example. So it says use the remainder theorem to evaluate when the function that you see here, when x is equal to -2. So they're asking us if x is equal to -2, what is the y value? In other words, what is f of -2? And remember, we're not going to use direct substitution. We're going to use the remainder theorem because that's what we're being told to do. So the remainder, we are going to use the exact same number that you see here because they already are giving that to you in terms of x equals to a number. They're not giving you x plus 2 as the divisor. So we don't change the sign there. Then we copy the coefficients of the dividend. So 3, 8, 5, and -7. As you can see, they're already in descending order, and we're not missing any terms in between. We have all the exponents in descending order as consecutive integers. so we don't need to add any placeholders for missing terms with a 0. So first step is to drop the first digit as 3, then -2 times 3 is -6. Then we add vertically, 8 plus -6 is 2. Then we multiply 2 times -2, that's -4. We add vertically or combine like terms, so 5 plus -4 or 5 minus 4 is a 1. Then we multiply 1 times -2, and that gives me -2. Then we add vertically, and that is -9. I'm going to repeat the steps. So it was, first you drop this number, then you multiply that number times -2, and then you obtain, no, not that one, oops. You obtain -6. Then you add vertically, and you obtain a 2. Then 2 times -2, and you get a -4. Then you add vertically, and you obtain a 1. Then you multiply 1 times -2, and you obtain a -2. Then you add vertically, -7 plus -2, and you get -9. So since the 3 is representing x cubed, this is x squared, this is x, and this is a constant, once you divide by something that it was of degree 1, then your exponents will go down by 1. So this 3 represents now, and remember this is, well, this whole thing is the quotient. So it is 3x squared plus 2x plus 1, and then minus 9 over x plus 2. But that was not even the question. The question was, what is f of 2? And so f of 2, by the remainder theorem that we see here, by the remainder theorem, f of -2 is equal to -9. For WebAssign, be careful. They might have already an equal, and then you just have to enter your answer as a number, or you might have to enter the whole equation, f of -2 equals -9. You could check your work by graphing it, or direct substitution, graph it, look at a table, I don't know. But on the exam, if I ask you to use remainder theorem, please use the remainder theorem. Okay, so we are almost done. We have 2 more slides. Great. And so now we're gonna combine the remainder theorem and talk about the factor theorem. So we already have been working a lot with, not a lot, but we did a couple of examples where the remainder was equal to 0. So if that occurs, if the remainder, and we looked at an example with long division is 0. So if the remainder is equal to 0, that means that this is a factor, right? The divisor happens to be a factor. But also, if that number that comes from it, actually I'm going to write it here. If the divisor is a factor, then k, x equals k, is actually a 0, or a solution to the equation, or it will show as an x-intercept. So that merged with the remainder theorem, it tells me that f of k is equal to 0, meaning that when x equals k, the y value is equal to 0. Or we could have the point k comma 0 as an x-intercept. So as you can see, they're all connected. And yeah, function value of k is equal to 0 because the remainder is 0 because x minus k will be a factor. And we could go from one side to the other and all of them in between to make connections. So that is the main purpose of this chapter. So x equal k is a solution because f of k is equal to 0. So it's a solution. We also call them roots. And we have that x minus k is a factor. And yep, that's it. So now let's do an example. So we have to show that x minus 2 and x plus 3 are factors of this polynomial. We have a polynomial of degree 4. That's important. That's the highest exponent. N equals 4. Just to remind you, if you were to graph it, you will have the end behavior that will be like that, both sides going up. And you could have at most 4 zeros. So let's see. We have to show that x minus 2 is a factor. So if that is true, then if x minus 2 is a factor, then x equals to positive 2 must be a 0 or a solution of the polynomial. So we're going to use synthetic division and put a plus 2 there. We're going to copy all the coefficients from here. We're not missing any terms. We have x to the 4, x to the 3rd, x to the 2nd, x to the 1st, and then the constant. So we're good there. We just have to be very careful with the negative numbers. So 2, 7, negative 4, negative 27, and negative 18. So first step, we need that to drop that first digit. Then we're going to multiply. 2 times 2 is 4. Then we're going to add vertically. 7 plus 4 is 11. Then 11. Tommy, stop it. 11 times 2 is 22. Then negative 4. Stop it. So negative 4 plus 22 is equal to positive 18. And then we're going to multiply 18 times 2. So that will give us 36. Negative 27 plus 36 is equal to positive 9. Okay, sorry about that. My dog, he likes to bark at every single person that walks by. Okay, so I checked my work. We're okay. Then I'm going to multiply 2 times 9, and that is positive 18. And then if I add vertically, negative 18 plus 18, I get 0. So that's like, yes, congratulations. Your remainder is 0. So that means that your x minus 2 is a factor. And that also means that from here, x equals 2 is a 0. Now, I'm going to teach you a trick to make your life easier. So right here, we have that 2 represents x cubed, 11 represents x squared, 18 represents x, and 9 represents your constant term. So instead of using the original coefficients to verify, we only verify that this one is a factor so far. We got a yes. So instead of going back to the original coefficients that you see highlighted in yellow, we're going to use the new coefficients, and this will make our life a lot easier. So, oops, that was a 2. So now we're going to say those coefficients. Well, let me just delete this. Okay, so those new coefficients. Now, if we want to test x plus 3, that means that we're going to use x equals -3. That's what we're testing. If x plus 3 is a factor, then x minus 3 should be a 0. So the number that we put here in the box is -3. So let's try this. We drop the first digit, then we multiply -3 times 2, that's -6. 11 plus -6 is 5. -3 times 5 is -15. 15 plus -15, I'm sorry, 18 plus -15 is 3. -3 times 3 is -9, and then 9 minus 9 is 0. So again, congratulations, you got a remainder that is 0. That means that x equals -3 is a solution. Which means that x plus 3 is a factor of the polynomial. Also, we could say that f of -3 by the remainder theorem is equal to 0, and also f of 2 is equal to 0. And one more thing, we could say that the x-intercepts will be -3, comma 0, and the other one will be 2, 0. And since this was a polynomial of degree 4, then the next 2 or the next 3 digits that we have for the coefficient will be representing 2x squared plus 5x plus 3. And if we had a question that was asking us to find the remaining 2 zeros, then that will be easy because we could factor this, or we could use quadratic formula, or we could find them with other methods that we will study on the next following sections. So at this point, what we did was we were able to prove that the original polynomial, I'm going to write it up here actually, 2x to the 4th plus 7x cubed minus 4x squared minus 27x minus 18 could be factored as the following: x minus 2, x plus 3, and then the other factor was the one that came from here, from this digit, so it was 2x squared plus 5x plus 3. That's how we factor it. So, and because the question was only to show that those two were factors, the question wasn't find all the zeros, so that's why I'm going to stop here. So thank you for watching.